So I put together this little doc, which I will share with you at the end, and I will also share with you kind of what the TOE file we're gonna build during the day. So this is like an overview of what we're gonna see today. So first part is gonna be like sticking to 2 dimensions and like GLSL tops, and kind of get a feel for like the syntax and get familiar with like the language. And then we're gonna move to 3D and see how we can also use all these techniques to kind of have more control on 3D system. So oh yeah, so one thing I should have shown. So the system we're gonna build is gonna be like a much simplified version of what I'm using to kind of animate all this like kind of anemone and like have all these like different variation per instance. And after that, we're gonna move to particle systems and how to use shaders to like animate a lot of different particles at the same time. And depending how we're doing at the end of the day, I'll like kind of give like an overview of geometry shaders and what can be done with them. So for particle system, again, I'm gonna show a brief example. So this system, for example, that takes a Kinect input is built already is built entirely in GLSL, and so I'm kind of like computing forces from the point cloud and then kind of feeding that into the particle system. So we're not gonna go quite as far, but we're gonna get the basics on how to do that. All right. So most of the time, I'm gonna set up my screen like this, so you can see both what I'm doing in TouchDesigner and the shader code. And I'm gonna try and like show the touch window so you can like follow along. All right. So first, when you start TouchDesigner, you're gonna see this. So the first thing, right click is to select a lot of nodes, and left click is to select like a single node. So first we're gonna get rid of the like default setup. So I'm hitting delete to like delete everything. And then we're gonna put down GLSL top. So you have 2 ways to bring the operators menu. So either you hit tab, or you can double click. So double click or tab. And here, if you kind of start typing, it's gonna highlight the operator that starts with the letter. So typing GL and selecting GLSL. So so by default, this operator comes with 3 duct text dots. So if you don't know what duct is, so you see these little arrows. So when you click on them, it's gonna kind of make appear and disappear these text dots, which are attached to the GLSL top. And so one is an info dot, and it's going to give you information about if the shader is compiling correctly. And another one is a text dot, and that's where you're going to write the code for the shader. And the third one, which by default is iconized, is another text dot which contains a sample code for a compute shader, but we're not going to go over that today. Maybe at the end. So here you can see you have this mode, And you can choose vertex, pixel shader, or compute shader. So by default, it's pixel. And here it points to the pixel shader the text that is used for the output. So first, a brief overview about how pixel shaders work. So I'm gonna kind of so imagine you have like a 2D image, and that's like your pixels. So each square is a pixel, and so the code you see in the fragment shader, so it's going to determine what's the color of this pixel, and the thing you have to, and it's being run on every pixel at the same time. And so instead of like a more traditional CPU programming language where you would like kind of do this pixel and then this one and then this one and then this one and kind of like loop over all the pixels, everything is executed at the same time. So it's a bit of a simplification, but let's say the driver tries to do the maximum of the work in parallel, and then it's like really optimized to like do as much as possible. But the thing is that the pixel, the only information you have is the position in the grid, and using that you have to like kind of make it do what you want. Yeah. So now by default you have this kind of sample code. So I'm gonna pull up my like little cheat sheet. Yeah. So first thing, which is kind of so GLSL is pretty close from the C programming language. So what it means is that contrary to Python, it doesn't care about tabs or spaces, but it does care about semicolon to kind of terminate the line. So one error that's going to happen to you a lot is if you forget one, and then, oh yeah, so this is not good. If you forget one, and then, so when you get this red and blue checkerboard, this is the default saying like you have a compilation error and it doesn't work. And here you can see where it tells you which line the error is. So it's going to say line 11, unexpected identifier, expecting semicolon. So then you go to line 11. And line 11 seems OK, but you have to kind of go back to see, oh, here I forgot my semicolon. Because the thing is, since it's looking for the semicolon, you can like kind of break code in multiple lines and kind of do that. And it's still going to work. Except, I mean, it's not recommended for legibility, but sometimes if you have like really long lines, you kind of want to do that. So I'm going to undo it. Another quick thing is comments. So you can have single line comments, which is 2 slashes. So if I remove that, then it's going to create an error because then it's trying to compile this and it doesn't know what example pixel shader means. And then you have also multiple line comments. So it's /*. You can, this is a multi-line, comment, and then the opposite, //. And so you can like write like longer explanation without having to do a double slash at the beginning of each line. Then the other thing compared to Python is that all the variables are typed. So you need to kind of declare their type before you use them. So we have like a pretty typical variables, so like integer, float, and then you have like vectors, which like contain multiple values. So a vector, it just means it's going to hold. So if it's a vector 4, it means it's going to hold 4 values. If it's vector 3, 3 values. Vector 2, 2 values. And so the typical use for a vector 4 is going to be a color, because you have 4 components: red, green, blue, and the alpha. And for vector 3, it's going to be like, let's say, a position, x, y, z, or a color without alpha. So some specificities of the GLSL language. So there are like multiple ways to multiple ways to initialize a vector. So you can either do, so if you only do one value, vec4 parenthesis 1.0 parenthesis, then the 4 components are initialized to 1, which you can also do. I'm going to declare another one, color 2, and I can do vec4, and it's going to be 1, 0, 0, 1. And so here I'm setting the 4 values. You could also do something more exotic. So you can do vector 3, and instead you can do vector 3, 1, and then 0. And this is also going to work. So what it does is the first 3 components are going to be 1, and then the fourth one is going to be 0. And if you're missing, if you like only, I'm going to leave this one. If I go back to this example and I remove the last bit, then it's going to give me an error. And it says too little data in type constructor. So the constructor is the vec4 parenthesis, and then you like give him data. And it wants four values, so if you're missing one, it's going to show you an error because it doesn't know how to construct the vector. So I'm going to kind of fix this again. So before I continue with the syntax, just a quick overview of the structure of this fragment shader. So first you have this keyword out, and you have this variable declaration. And out means it's going to be the end result. What you the final color you're writing needs to be assigned to this variable. So it can be anything. So if I rename if I rename this to frag color 2, it's going to throw an error because it says, okay, I don't know what frag color is. If I comment this line out, it actually compiles, but it doesn't write anything. So you still see the checkerboard. And if I do 2, then it's going to compile as you want. So I'm just going to go back to this. And then you have this block. So it's so main is a function. Void means it doesn't return anything. There's no return statement at the end. And main means like it's the main, is the core of the shader, because you can also declare your own functions, and then you can use them inside. So this block like always needs to be present in the shader. Okay. So yeah, now I'm gonna do this split. And edit this. So one thing that the touch editor is missing is syntax highlighting. So that's why it can be nice to kind of use a separate editor. The easy way to set this is if you go to Edit, Preferences, and you go to DATs. And here, Text Editor, you can choose an external text editor. So on Windows, I kind of like Notepad++ because it's free. There's also Sublime that a lot of people really like. Whatever works for you. Um, and then the thing is, anytime you kind of edit something here, so if here I do 0.5, you have to save the file. And so I'm hitting Control S in Notepad++, and it's going to update. It's going to recompile the shader code. It's going to update in here, in Touch, and update. All right.
Sorry, how did you open that file in the exits?
So when you select the DAT, then in the parameters on the File tab, you have this little edit. And I think if you don't have anything set up, it's just going to use the default text editor from the OS. So yeah, I'm not super familiar with Mac, so I don't know if you have a nice one. I know the Windows one is like not so good, the default Notepad.
So how do you specify it?
So you go to Edit, Preferences, DATs, and Text Editor.
I think with Mac, it's on TouchDesigner.
Yeah. Also, of course, if you have any question, don't hesitate to interrupt. You open the GLSL compute?
Yeah, but not started.
Oh, so if you click on these little arrows, you can like kind of make them all appear and disappear. So you want to make sure you hide the compute one, or you can like even delete it. And then you want to make sure you're like selecting the pixel one and hit edit.
How did you get the information, compiling information?
So this one, the info, it should also come when you create a new one. It's going to come here. And if you hide it, you kind of like click on the little arrows. If you create a new one. Oh yeah, so you click on the little arrow, the other one. The next. Yep. Oh, okay. Oh, so for whatever reason, it seems on a Mac, the info that is not automatically created. So if you're on a Mac and it looks like this, you double click, you go in that, and here you tap info. And then you're going to have this empty info dat. And then operator here, you can drag and drop GLSL. More general TouchDesigner information. So it's recommended to kind of save your file regularly in case you crash. TouchDesigner is pretty stable in general, but you can encounter kind of drivers bug, which are like, and since it's like tied to the graphic card, it can like crash pretty suddenly. And one thing that is useful is if you go to preference and general. So I think it's the default now, but there is increment file name on save, and you can choose whether it's off, on, or you can also leave it on and copy to backup folder. And if you do that, so just going to show you. So you kind of want to like save file in a folder. I don't know. Oh yeah, I think it's. I think there's something. Yep. Oh, it's here. So I'm gonna call it workshop. So now you can see the name is here. And now if I hit Control S, it goes 0.1. If I hit Control S again, it goes 0.2. And if I go to the folder, you can see this backup folder was created, and it put the 0.1 inside. So the nice thing is like it's going to store all the intermediate version, and then you can like clean it up. but if you like somehow want to go back, that's a nice thing to have. So one last thing about this info that wasn't created. So if you want to kind of have the ability to kind of hide it, you can right-click, and you can do doc2, and then you select the operator, and then it's going to add this little arrow, and now you can hide it if you want. And if you want to undo that, you can right-click and do undock, and now the little arrow is gone, and it's like independent again. All right. So one last note for like the kind of the basic, the sample. So you get this, it's a TD function called TD output swizzle at the end. So this is a TouchDesigner specific function that is used to make shaders compatible between Mac and Windows. So so one thing that's very helpful is when you select the GLSL top, you have this little help you can click, and then it's gonna pull the docs. And then if you go to write a GLSL top, you're gonna get like a lot of useful information on all the kind of things specific to touch regarding GLSL. And so now if I just do output swizzle, so the order of the color channels is different on Mac and Windows, so it just takes care of that. So you just leave it at the end and don't worry about it. All right, so now I'm gonna make this little square blue. So I'm gonna delete these two lines and declare a vec4, which is red, green, blue alpha. So 0, 0, 1, 1, and save. And now it's blue. And another specificity of the GLSL language and shader language in general is called swizzling. And it's the ability to kind of select components of vector in like a kind of light way. So one thing I can do is I could, so if I do color equal color dot RGBA, so here I'm not changing anything. But if I want to swap the red and blue, for example, I can write color equal color dot, so I'm going to do BGRA. And if I save that, so now the vector value, instead of being 0011, it's going to be 1001. So it's pretty useful in a lot of circumstances. For example, if you want to do things with just the red, green, blue and not touch the alpha, you can like declare a vector3, which is going to be color only. And you can say it's color.rgb. And what this does, it's going to copy the red, green, blue component into this new vector and kind of leave the alpha alone. So you have 3 different types of swizzle operators. It's meant to be kind of useful to like know what you're dealing with. So you can use .rgba. You can use x, y, w, zw. So if instead of this I write color equal color dot, so it's going to be z, y, x, w, it's going to give me the same result. And the same, because I can also write color equal color x, y, z, w. And this is like the same. And the last one, which is less used, it's stpq. So if I do color.stpq, that's the same. And if I like want to swap again, I can do ptsq, and that's gonna go back to blue. One thing you have to be aware, if you can't mix those, so you can't do RGX or you have to like kind of stick to one of these three for like one query. So you have like a lot of documentation on the Kronos website if you want to know more. So for example, so you have like all the different data types, all this. If you want to know more about the out keyword, like you can like go there and it's explaining everything.
Yeah.
So just a little kind of recap on the on TouchDesigner. So when you click this little house, you go to root, and you have kind of this container created already. And so to navigate in, you can either zoom in. I think by default you can go in. I turn it off because I rather double click. Or you can also hit enter when selected. And then you can see you're inside project one. And that's kind of like a typical file folder, like Windows Explorer or the Finder on a Mac. And so it seems on Macs, shaders, you get shader compilation errors when you're like doing stuff at the root. I think on Windows, I mean, maybe it changed, but if I do this, I mean, for me, it still works. So yeah, it's a little quirk. Anyway, I think maybe yeah, it's good that like we figure it out. Okay. So another question is, what if we want to animate this color using other data coming from Touch? And how in general can we like kind of animate value in the shader? Because this is compiled, and so if you like edit the code and compile again, it's a slow process. So we're gonna use what is called a uniform. So uniform is a special type of variable. So you still declare after the keyword uniform, you're still gonna declare the type of the variable and the name of the uniform. So in the sample code, you have this example uniform. So we're gonna create a new one. So I'm gonna do this again. Yes. So I'm gonna type uniform. It's gonna be so we're gonna do a vec4, and we're gonna call it u color. So in general, I think it's good practice to, when you declare uniform, to start with the lowercase u, because then when you see them in the code, you know this comes from outside of the shader, and you can't override them inside the code. If you want to modify them, you have to copy them to a new variable. So I'm going to do this. And now at the end, I'm going to type color equal uColor and compile. So now we lost our color. So the gray checkerboard is fully transparent. So it means everything is 0. The nice thing, so it's only in the latest version of TouchDesigner after the series 2018-23,000. So you see this little warning, and if you middle click. So middle click, you can get all sort of information. And it's going to tell you, warning, uniform uColor is unassigned. Please add it under page vector 1 or vector 2. So this is new, and it's nice because if you like make any typo, it's going to like also tell you about them. So now I'm going to select the top. So you see you have all these tabs at the top. So I'm going to select vector 1. And here I can declare a uniform name, and this has to match what I declared inside of the shader. So I'm going to type uColor and hit enter. And now what we see is this light red. And that's why I picked up this value, which is 0.5000. And so now I can, like, if I want full red, I can like do one here and one in the alpha. And now you can see it's animating my color. Yep.
Why can't uniform be a vec3?
So it can be a vec3. So let's see what happens if I do a vec3. So if I do a vec3, then I get the checkerboard because I'm trying to assign a vec3 to a vec4. So it's confused about the first coordinate. But what I could do now is say, OK, the color is going to be vector 4. It's going to take the 3 components of my vec3, and then I'm going to add 1. And now this is working. So you just want to make sure you always kind of assign variable that like are the same types. Otherwise, it's going to throw an error at you. So since we were dealing with color, and the end result is this vec4 color, I was just doing a vec4. Maybe I'll leave it like this for now. And now what we can do is use all the kind of touch operators to kind of animate this color. So if I go to the chop tab and I hit LFO, so you have this animated value. And now what we want is the red to kind of like oscillate. So what I'm going to do is for the red component of the color, I'm going to type OP, quote, single quote, LFO1, and brackets 0. And now you can see, so this value follows this value, and the square is animated.
Can I ask you a question? What's the difference between using the Python expression in there and just like exporting the chop?
So I think it's a matter of preference.
Okay.
Historically, exports were faster. Export can cause, I feel that it's easy to like get into weird issues when you kind of develop things and copy paste, because exports are not copied, and then if you want to like duplicate things. So the thing is, so if you use a Python expression, it used to be a little slower. But in the last version, they do something which is like optimize the Python expression. So you can see here, if I hover, you can see this little optimized. And that's mean it's being like optimized. And it's pretty much the same speed as exports.
Okay.
So now it's really down to a matter of preference. Export, the nice thing is you can like kind of, you can like create a script to kind of fill in a table that's going to set all the exports you want. So sometimes it can be advantages. It's so. A little note for people new to TouchDesigner. So once I have my expression here, if I click here, I can toggle it off, and I can like kind of manually set the value. But the expression is still there. So that's like an easy way to kind of test. And the green export is if we had an export setup, then we could also kind of switch. But things are still like saved, and you can like animate them. Yep.
Is it technically the same with exporting null channel and then dragging to the chop?
Yeah, so I'm going to show the export way too. So if you want to do an export, I'm going to select the LFO1. I'm going to click this little viewer active. And now you can see I have this different arrow when I hover and it turns green. And now what I can do is drag and drop here. And you see I get this little plus. And I get export chop option. And so that's an export, which is just a different way to kind of animate this parameter with this value. And now I can toggle between my Python expression and the export. Yeah, so that's a little outside of the scope of today, so I'm not going to. Okay. So one thing that's nice in TouchDesigner, it's pretty easy to actually see the color values. So there are like different ways to do that. One is to click the viewer active, which is this little cross here. And then here you can right click and you can do display pixel values. And now when you move your mouse around, so you can see the, I'm gonna stop the, yeah, I'm gonna stop this for a second. So you can see my value is, so it's 0.4498 in the red and 001. So now if you're wondering why it's 4498 instead of 0.5, that's because if you middle click, you can see we're using 8-bit fixed colors, which is like the precision of the color. So it means it gets quantized to 255 values. So it's 1.7. But if I were to change the pixel format to 16-bit float, now you can see I get 0.5. So I'm gonna don't think too hard about it. I'm gonna explain that more later. And so that's a like kind of easy way. So and the other way is you can use a top to chop. So this one, and then you can drag this top here, and then it's gonna. It has multiple way of like sampling the top. So by default, it's gonna be a row, and you can see the values for the whole row. Just to make it a little more, yeah, I'll just stick with that for now, and we'll like get more in depth later. So that's it for this very simple one. We're gonna pick up speed as we go. So to keep things tidy, I'm gonna create a little container. So I'm gonna go to comp and create a base, and I'm gonna rename that basic GLSL top. I'm gonna select everything, cut and paste. And so now you can see I'm inside project 1, basic GLSL top. I'm going to reactivate the... Okay. Everything's good? Okay.
What was that last step you just did? You made a component?
So if you double click in the comp section, you can create what is called a base, which is just like a simple folder container thing. And then I kind of entered it, and I copy paste, I cut and paste what I had. just to keep things tidy. And I'm going to create like a new one for each new sample.